Welcome to our journey through the cosmos. Today, we're embarking on an awe-inspiring exploration of the vast structure of the universe, focusing on a remarkable feature known as the cosmic web. Imagine standing beneath a night sky, the stars twinkling like diamonds scattered across a deep velvet canvas. Each point of light represents a galaxy, a distant world filled with its own wonders and stories waiting to be told. Yet, these galaxies don't float in isolation. They are part of an extraordinary interconnected structure that defines the very fabric of the universe itself. The cosmic web is the large-scale structure of the universe, a magnificent network composed of galaxies, galaxy clusters, and immense voids that stretch across the cosmos. Picture it as a colossal tapestry, intricately woven from the threads of gravity, dark matter, and the expansion of space itself. This remarkable structure reveals the underlying forces that shape our universe, offering a glimpse into its past, present, and future. As we delve deeper, we see that the cosmic web is not merely a collection of celestial bodies. It is a dynamic interplay of forces acting over billions of years. The patterns we observe today are the result of cosmic events that have sculpted the universe since its inception, events like the Big Bang, which set the stage for everything that followed, to the formation of the first stars and the merging of galaxies over eons. Each of these events has left an indelible mark on the structure we observe today. The cosmic web serves as a reminder of the universe's vastness and complexity, inviting us to ponder the intricate processes that led to our existence. At the heart of the cosmic web are galaxies, the fundamental building blocks of the universe. These sprawling collections of stars, gas, dust, and dark matter are not scattered haphazardly across the cosmos. Instead, they are organized into clusters and superclusters, forming dense nodes within the web. Gravity, the force that governs the motion of celestial objects, plays a crucial role in this structure. It creates gravitational wells that attract more galaxies and dark matter, shaping the cosmic landscape. As galaxies collide and merge, they form new structures, leading to a breathtaking variety of galaxy types: spirals, ellipticals, and irregular forms, each with its own unique characteristics and life cycles. These interactions are not just random occurrences. They are significant cosmic events that have profound consequences for the galaxies involved. When galaxies collide, they can trigger bursts of star formation, igniting new stars from the gas and dust caught in the gravitational dance. Imagine the scale of these interactions. Entire galaxies, each containing billions of stars, engaging in a slow-motion dance over millions of years. Each collision is a moment in the grand narrative of the universe, a story of creation and transformation unfolding across the vastness of space. Through this process, new stars are born and existing ones evolve, ultimately leading to the diverse array of celestial objects we see today. Now, let's turn our attention to dark matter. This mysterious, invisible substance makes up about 27% of the universe and is essential for the formation of the cosmic web. Though we cannot see dark matter directly, we can observe its effects through the gravitational influence it exerts on visible matter, such as galaxies and galaxy clusters. Without dark matter, galaxies would lack the necessary mass to hold themselves together. Imagine a universe where galaxies drift apart into isolation, unable to form the intricate structures we observe today. Dark matter acts like a cosmic glue, providing the scaffolding that holds galaxies together and facilitates their interactions. Then we encounter dark energy, an even more enigmatic force that constitutes roughly 68% of the universe. Unlike dark matter, which pulls objects together, dark energy exerts a repulsive force, driving the accelerated expansion of the universe. This phenomenon creates vast voids between clusters of galaxies, pushing them further apart over time. The discovery of dark energy has profound implications for our understanding of the cosmos. It challenges our previous notions about gravity and cosmic dynamics, suggesting that the universe is not only expanding, but that this expansion is accelerating. This realization invites us to reconsider the ultimate fate of the universe. Will it continue expanding indefinitely, or will gravitational forces eventually bring it back together? These questions underscore the mysteries that still elude us, reminding us that our understanding of the universe is continually evolving, and that the cosmos holds secrets yet to be uncovered. The cosmic web encompasses not just clusters of galaxies, but also enormous voids, regions that are almost devoid of matter. These voids can span tens of millions of light years, creating expansive areas of relative emptiness surrounded by dense filaments of galaxies and dark matter. These voids may seem desolate at first glance, but they are crucial to the universe's architecture. They create a balance to the densely packed regions and allow for the movement of galaxies, influencing their interactions and the dynamics of the cosmic web. Within these vast, empty spaces lie the seeds of future structures, waiting for gravitational forces to coax them into formation. It's fascinating to consider that these voids, while seemingly barren, are not truly empty. They contain a lower density of matter, including gas and dark matter, which may one day coalesce to form new structures. The interplay between filaments and voids creates a cosmic landscape rich with possibilities, where the dance of galaxies continues unabated. Astronomers employ advanced telescopes and comprehensive surveys to map the cosmic web, illuminating its intricate details. Projects like the Sloan Digital Sky Survey and the Hubble Space Telescope have provided invaluable data, revealing the large-scale structure of the universe and helping us piece together its formation and evolution. With each observation, we uncover new layers of complexity. This ongoing research enables us to refine our models of the universe, enhancing our understanding of how galaxies form and evolve over cosmic timescales. The cosmic web is a testament to the interplay of forces that have shaped our cosmos, revealing a universe that is as intricate as it is beautiful. From the discovery of new galaxy clusters to the identification of previously unseen voids, each breakthrough deepens our appreciation for the complexity of the universe. These findings not only enhance our scientific knowledge, but also ignite our imaginations, inspiring future generations of astronomers and explorers. The cosmic web is not merely a scientific concept. It is a breathtaking testament to the complexity and beauty of the universe. From the intricate dance of galaxies to the mysterious forces of dark matter and energy, each thread in this web tells a story of cosmic evolution. As we continue to explore and understand our universe, we find ourselves pondering profound questions about our existence. Are we simply observers, or do we play a role in this grand cosmic tapestry? What does it mean to be part of a universe so vast, so interconnected, and yet so filled with mystery? Thank you for joining us on this exploration of the cosmic web. The universe is vast and full of wonders, waiting to be discovered. So, keep looking up, for the cosmos has much more to reveal, and every star you see is a reminder of the beauty that lies beyond our world. Let's embrace the spirit of inquiry and continue our quest to understand the universe we inhabit, for in every question lies the potential for discovery.